Okay, this recording is going to take you through electron configurations and how to create electron configurations. So the first thing I'm going to show you is how to write the grid that will help you write them in the correct order by lowest energy to highest energy. So we've learned about quantum numbers. Quantum numbers are n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. Let's go, n equals 6, n equals 7. Okay, these represent the energy shells that the electrons are located on. All right, and then each energy shell or each quantum number has specific suborbitals that you will find in that particular energy level. So n equals 1 has what we call 1s, n equals 2 has a 2s and a 2p, n equals 3 has 3s, 3p, 3d, 4 has 4s, 4p, 4d, 4f, 5 has 5s, 5p, 5d, 5f, 6 has 6s, 6p, 6d, 6f, 7 has 7s, 7p, 7d, and 7f, and that's the highest we're going to go for this particular class. So in order to figure out what you fill first, you're going to create this grid. Okay, and to fill, you're going to go diagonally. So you'll fill the 1s first, and then you'll come up here and go diagonally to the 2s, and then to the 2p and 3s, and 3p, 4s, 3d, 4p, 5s. Okay, and you keep going like that to fill. Now remember, s holds 2 electrons, p holds 6 electrons, up to these numbers, d holds up to 10 electrons, f holds up to 14 electrons. So when we write our electron configurations, we're going to be identifying the suborbitals, and then we're going to use superscripts or exponents to represent the number of electrons in that particular suborbital. So let's do something easy. Let's start with carbon. Okay, carbon is C. It's right there. It's atomic number 6, which means 6 protons, and because we're dealing with neutral atoms, it will be 6 electrons as well. So carbon has 6 electrons. So we're going to start over here and follow these arrows over here. Okay, so we start with the 1s, and s can hold up to 2, so we put a superscript of 2, and then we go to 2s, 2, and then 2p, and we add up these exponents. So our 2p, since we only need 6 electrons, we've already represented 4. We only need 2 in that 2p. Okay, so your exponents should add up to the number of electrons that you're representing for that particular element. So that would be carbon's electron configuration: 1s2, 2s2, 2p, I deleted, 2p2. All right, let's do another one. Let's do, change the color. Let's do magnesium. Okay, magnesium is 12. So Mg, we need to represent 12 electrons. All right, so we start with 1s2, 2s2, 2p6, 3s2. And we would stop there because when you add up these exponents, 2 plus 2 plus 6 plus 2, you get 12. So that is your electron configuration for magnesium. 1s2, 2s2, 2p6, 3s2. All right, so let's do an even larger one. Let's do a different color. How about purple? And we'll do it, I guess that's thick. All right, so purple. Let's do, oh no, let's do tungsten, W. Okay, that's 74 electrons, so W has 74 electrons. So we would start with the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, trying to count these in my head, 4p6, 5s2, 4d10, here's the tungsten, 4d10, 5p6, 6s2, comes after 6s, 4f, 14, and 5d4. And that should add up to 74 electrons if you add up all of those exponents. So you can do this with any element on the periodic table. You can practice with any element on the periodic table and on your own time, but that is essentially how you do electron configurations. Now, noble gas notation kind of shortens these. Okay, so with tungsten, since that one's so long, we would want to do a noble gas notation. And to do that, you find the noble gas that comes before the element. So tungsten is W. If you go up, here, let's look at the periodic, make the periodic table a little bit bigger. If we go up a row and then all the way to the end, that's the that's going to be the noble gas that comes in front of it. So it's on the row above at the very end are your noble gases. So xenon is the noble gas that comes before tungsten. So to write tungsten's noble gas notation, we put xenon in brackets. And then we follow up with what's left. Noble gases always end on a P, I'm sorry. So the last P that was filled, and then you take whatever's after that P and you put it behind it. So 6s2, 4f, 14, 5d4. So that's going to be the noble gas notation for tungsten. You don't have to write any of that extra stuff. So that's how you do the noble gas notation and how you do the electron configurations. So practice those, and if you have any questions, email me.